Question number 12. You're expected to predict A, B and C in the following reactions, which are basically hydrolysis of ionic carbides. So what's the way to approach this, Gopi?
Now, in the ionic carbides, the metal is positively charged and the carbon atom is negatively charged. In other words, we can say that this ionic carbide supplies carbon ion to the reaction. Now, in the first thing,
let's look for carbon ions, right?
Yeah, first we have to look for carbon ions that are being supplied.
Okay.
Now, in Al4C3, aluminum is in +3 oxidation state. So 4 aluminiums are in +12 oxidation state. So 3 carbons share a charge of -12.
Which means they're all -4.
Since for carbon only -4 is, at max -4 is possible.
Okay.
So C3 -12 implies C -4, C -4 and C -4. Whereas if you take for calcium carbide, that is CaC2, calcium is in +2 oxidation state. 2 carbon atoms are sharing a charge of -2. So C2 -2. The only structure possible is this one. Whereas if you take for Mg2C3, magnesium is in +2 oxidation state. So these 2 magnesiums will be in +4 and 3 carbons will share a charge of -4. Now if you draw the possible structures for it, you will get one structure like this and another structure like this. Now, second thing.
So it'll be a minus charge and a minus charge? Are you sure, students? Or do you think it should be a minus charge and a -3 charge in the beginning?
Yeah, that is. It should be -3 here.
Exactly. So please pay close attention to what we are solving.
Now, next thing, we have got carbon ions and we have water in the solution. That is, so this carbon ion extracts H plus from the water.
Okay.
Now write down the possible products.
So we're now going to add an H plus to all the carbon ions and try and see what are the products we can get, right? Okay, so for the first one it's C -4 and H plus. So we directly get CH4.
Yes. For this, it will need 2 H plus ions.
Okay.
You'll get
basically
acetylene.
getting acetylene. All right.
Now if you take this structure, it needs 4 H plus ions. It will get converted to H3C, C triple bond CH.
Okay, and for the last one?
And for the last one, finally you will get, it also needs 4 H plus ions. And you will get an alene. C double bond, C double bond, C. This is called as an alene.
Alright. So, tell me this. Amongst the last two, which is the alene that we've gotten in CH3C triple bond CH, which compound has a higher likelihood of being formed?
Both of them have equal probability because we are given the structure, like we have not given the exact structure for it because we are just told it is Mg2C3.
Okay.
Now this C3 -4 can contain either of these two structures.
Okay.
But here in the question it is not specifically mentioned which structure is given.
Alright, so we don't
have
really
to
need to worry
consider
about
all
that.
the possibilities for it.
Okay, so we can't assume just one possibility.
Yeah.
If we have to look at the two structures, which of these two structures do you think is more stable as such? So if we see, the first structure has a -3 charge on a carbon, which is it in conjugation with the triple bond that's present there?
No. Yeah, it is in conjugation.
So
if you take.
Okay, so if we take it in conjugation, what does it give us? Let's try and explore further.
Yeah. -2 minus. It's same as the second possible structure for it.
Exactly. So as you can see, the carbon that will actually, the C3 that is actually associated with Mg2 is in conjugation, and as a consequence of it, both of these are different hyperconjugating structures of the same compound. So they're both equally likely to be formed if we look at it.
Now,
right?
Yeah.
Okay.
One more thing I need to stress here.
Okay.
Now, beginners do think that whenever you are given this question, what beginners think is you are given a carbide, so directly you will get CH4. They think this because they are not taught the mechanism in the beginning of it. So, but if you look into the mechanism as what I have taught here, considering all the possible structures and all, it's quite obvious that the structures will be different for different carbides.
Okay.
So, I want you to try for one more thing. What if I give silicon carbide instead of this? I want you to find out the answer for it. I'll give you a hint if you want. Silicon carbide is covalent. All the compounds which are given to you are ionic carbons. Now, if you want the answer for it, go and search in your inorganic chemistry.
And so, as students, as you can see, the JEE syllabus is very varied, and some of the best problems that come in IIT JEE are problems which correlate to different concepts that you've studied. So it could just be in physics, as we see, there are questions that combine simple harmonic motion as well as fluid mechanics or rotational mechanics. The same way in chemistry, when they mix questions across organic and inorganic chemistry, as we call it, you get some really interesting questions, and that truly tests the students. So go check this question out, and if you can't find the answer to it, you can look for it in the manual that is provided to you, and the answer will be available there. Yeah. Alright, let's move to the next question, Gopi. Alright, so question number 13, fairly straightforward. What are A and B in the following reactions?
So, first, see what are the reactants given to us. You have alkyl halide, sodium in presence of dry ether. Now this suggests that this is Wood's reaction.
Okay.
Now if you remember the Wood's reaction, you have Rx plus 2Na plus Rx. You will get RR plus NaX. So for the first case, if you take CH3CH2Br plus 2Na plus Br CH2CH3, you will get butane plus 2NaBr. Yeah.
So basically you just remove those bits in the box and just join together the
This
rest
is
of
the
it.
way of memorizing this reaction.
Yeah, very simple. So let's quickly solve the second question as well. Seems easy.
So for
only.
the second case, if you write plus 2Na plus Br, now couple these two products, you will get 2NaBr plus compound. That's it.
So seems fairly straightforward, right? But I kind of have a inkling about the second one. Something seems wrong. Like JEE will not have such easy questions, right?
You are correct.
Okay.
The first thing is correct.
Okay, alright.
But the second one is false.
Alright, and why is that so? Should we look at the reaction to try and understand?
Yeah, we should look into the mechanism of it.
This is why you need to know mechanisms, guys, because if you don't know them, you will mess up questions like these, and this is what JEE is particularly prone to do as well. They will find those trick questions where you will mess up. So let's try and understand this through the mechanism.
Now for Wood's reaction, two mechanisms were proposed. One is free radical mechanism and the other is Carbanion mechanism. So first we have sodium in the mixture. Now since it's a metal, it loses its electrons to give Na plus and electrons.
Okay.
Now if you look into it, alkyl halide, now this is more electronegative atom, so what happens is you will get R plus X minus.
Okay.
Next, I've told you that Na loses its electrons, so if you add electron to it, you will get either R free radical or R minus. Now think, for the second question what we have given is, you will get either this radical or this carbanion.
Okay.
Now it is a tertiary carbanion. You know that methyls are plus I groups. I mean, this shows plus inductive effect
Yeah.
by donating the electrons. So this is destabilizing this carbon because it's increasing the negative charge on this carbon atom.
Yes.
So this is not formed.
This is not formed at all, or is this found
not
rarely?
formed at all.
Okay, because this is a highly unstable
Yeah.
product.
But if you take this one, you will have hyperconjugation from these hydrogen atoms.
Okay.
Let me show you what it is. It's free radical.
All right.
This is just the mechanism of hyperconjugation.
Okay.
So, for this compound, you have 9 hyperconjugation structures possible. 3
Okay.
from each methyl group. So, if you just couple these, you will get this compound. But it's not formed, as I said, because these 3 methyl groups are very bulky and it's very difficult for these two to couple because they suffer hindrance because of presence of these methyl groups. So,
Okay.
if you remember the coal-based electrolysis, as I've told you before,
Oh, so where we had a very similar compound like this, right?
yeah,
Okay.
it loses H, you will get a biradical ending up with an alkene. This is formed 100%.
Okay, so basically at the top of the question where we actually began, the product B is going to be not really a conjugated, not really a structure with 2 R's, but is actually going to be an alkene as such.
Alkene, yes.
And this is something you guys should always keep in mind, because these are the kind of questions that you will find in JEE where they'll tell you find out what is A and what is B, and you can easily mess up such a question. So let's move on to the next question. What are A, B, C, D and F? It's a very interesting question. I've always been fond of these questions which look like treasure hunts, where you first get A and then you get B and then you try and get them based on the last clues that you have. So my enthusiasm for this question aside, let's try and find out what A is going to be. What do you say, Gopi?
To solve this question, first thing, what are the reactants for us? You have an alkyl halide, and also you have an alkyl halide, and also you have a metal lithium.
Okay.
First, lithium is a metal. As a tendency of a metal to lose electrons, lithium loses its electrons to give Li plus ion and electrons. Now, in the alkyl halide, now for a while let's treat this as R. RCl, and this as X. Now X is more electronegative than carbon. What you have is R plus X minus.
Okay.
Now lithium gives electrons to this carbon, this R plus, then you will get R minus, Li plus, and this is stabilized by Li plus. Ionic forces exist between them.
Okay.
So you have your A is equal to CH3 minus Li plus. You got your A now.
Okay, which is R minus Li plus.
Yeah.
Okay. So let's throw in some CuCl into the mixture and see what happens.
Yeah. Now whenever you react RLi with CuCl, what you get is R2CuLi. This is an inorganic reaction and no mechanism.
So what will be the charge on copper?
The copper is in +1 oxidation state and lithium is in +1 oxidation state.
Okay.
And each R is in -1 oxidation state. So
Okay.
this R2CuLi will give you carbanium, which is R minus.
Alright.
So now first go to
This is a bit like the Grignard's reagent, right? An organometallic compound?
Yeah, it's an organic metallic compound.
Okay.
So
what is B right now? So B is R2CuLi.
yeah.
Or is B CH3
Yeah. Where you have R is equal to CH3, you have B as CH3 twice CuLi.
Okay, alright.
Now let's go into the next part of it. That is B on treating with C2H5Cl. Now for a while treat this C2H5 as R dash. So what you have is R minus plus R dash X. This R minus substitute this and you will get R and R dash plus you will get CuR dash plus LiCl.
So
Where
we will
this
get
R is from
CuR dash or will we get CuR?
CuR dash.
Okay, alright. So if you look at it, so what are the products that we are actually getting if we substitute R and R dash in them?
Yeah. CH3, C2H5.
Okay.
Now this is your R, and this is your R dash. So you can see that you have got an unsymmetrical alkane with it.
Okay, and CuR dash will be CuC2H5.
CuC2H5.
Okay. Students, you'd be quite intrigued and interested to know that what we've just managed to decipher or solve, this pathway from CH3Cl all the way to CD and E, is actually the Corey-House synthesis. A very interesting synthesis that was created to be able to produce unsymmetrical alkanes. And well, it's just an interesting treasure hunt that we've just been on. Now that we've gone on this side note, let's come back and try and solve it for F, because that's the only one remaining, right?
Yes.
Okay.
You got B as CH3 twice CuLi.
Alright.
Now this one you have treated with this compound. If you directly write the product like the Corey-House synthesis, you will get this is R dash and this is R.
Alright. But lots of steric hindrance by the looks of it, right?
Yeah, you are correct. So this reaction won't occur because I already told you that this proceeds via SN2 mechanism. That is, CH3 minus attacks this carbon from the back side. So you can see these three methyl groups are providing steric hindrance to this carbon. So what happens here is, instead of substitution, you got an elimination product. I mean to say that CH3 minus is taking hydrogen from this and this is leaving. You will get this
An alkene.
alkene again.
And a CH4, right?
Yeah, and a CH4.
So again guys, as you can see, alkenes seem to be a very favorite question in the concept of alkanes as such. So always remember, whenever you see a compound with steric hindrance, remember that there's going to be a trick about it, and especially because these are tricky, these are the kind of questions that will get asked in IIT JEE when you study, because they're going to test if you truly understand the concept or not, and if you're able to adapt to changes that come in at that point of time. So now that we're done with this, let's move on to question number 14, or do you have anything to say, Gopi?
If you want to know more about it, look for E2 mechanism and SN2 mechanism. You will get the E2 in alkenes chapter and you will get SN2 in alkyl halide chapter.
Alright, on that note, we'll sign off and move on to the next question. Explain why the following molecule is highly reactive towards decarboxylation in the presence of sodalime. Also, what would happen if it is simply heated?
Decarboxylation is nothing but removal of CO2. Now, sodalime is NaOH in the presence of CaO. Now let's see what happens in this mechanism. as I told you, it's removal of CO2. You are getting CO2 as a product. Now calcium oxide reacts with CO2 to give calcium carbonate. So it's removing one of the product of the reaction. As a result of it, the reaction proceeds forward, as you can see it by Lee-Chatela's principle. Now let's look into the mechanism of it. First, in this molecule, this is in resonance, and what happens is you'll get CO2 leaving a carbanion. Now if you see this negative charge is in conjugation with this double bond, so you can have a structure like this one. So the formed carbanion intermediate is highly stabilized by presence of strong electron withdrawing group, which is C double bond O.
Okay.
So it's because of this one, this is highly reactive.
Alright, so we now have the explanation for why it's highly reactive. Now, what would happen if we simply heated this compound as such?
If you just simply heat this compound, the same thing will happen, because as I told you, this is in resonance with it. So, so you'll get the same carbon.
Okay. So if we just simply heat it, we will have the evolution of O2. We'll have the evolution of CO2 as such, because it has a tendency to want to break off because the intermediate is very stable. Yeah. And as we told you earlier, CO2 is a compound that releases a lot of energy when it's created.
Yeah.
Because it's a very, very stable compound.
Yes.
Right?
Yeah.
And which is why even on heating it, we'll get the same result as such.
Yes.
Okay.
I want you to try one more thing. What is the product obtained when this compound is treated with sodalime?
Interesting. So this is going to be a very interesting question if we try and solve it. Gopi, would you like to give them any hints?
Okay, I'll give them hint. First, as like the previous example, you have COOs here. If they do it, they'll end up getting this compound. But this is not the product.
Okay, so this is not the product. So you've told them what the answer is not. Alright, how about we help them find out what the answer is as such?
The reaction won't occur in this case.
Oh, so we won't have a reaction at all. And why is that specifically so?
Because if you see this carbon is a bridgehead carbon for these bridges.
Okay.
So this negative charge can't be in resonance with this, because double bond and a bridgehead carbon is highly unstable because of the angle strain here.
Okay, and they're also not planar as such.
Yeah,
right?
they are not planar.
And that is the reason why they can't be in resonance consequently. Yeah. So even though, as you guys can see,
as such it will remain in this state, or mostly it will remain as the previous compound itself. I mean this one.
Oh, so it won't react at all. We will just have the following compound consequently. So yeah guys, be very, very careful. We have a tendency, we see a negative charge and we think, oh, negative charge, single bond and a double bond, this is going to be in resonance. But you've got to be very careful, and this is one of the first rules of resonance, where they tell you the bonds must be in the same plane, right?
Yes.
And this is what this question is demonstrating as well. So, and these are exactly the type of questions that JEE will test you on, because they would want to see how truly well have you understood all the concepts related to that particular topic. So with this, we're done with our questions on alkanes. Let's move on to the topic of alkenes now.
Yeah.